rationalize, and there's actually a little bit more. You're actually rationalizing the denominator.
Mhm.
And there's these kind of these rules in math. It's like, well, you can't leave a fraction in the bottom of a fraction. Okay, that's like one of those things that you can't do. All right. You generally don't leave it like 3 minus minus 4. So these are like conventions that we use. Rationalizing the denominator is one of those conventions. Okay. So for example, let's say it's 4 divided by the square root of 2. Even though this is like fine, it's not pretty. It's like this, it's like, oh, this isn't right. So they really make a big deal out of rationalizing the denominator. So that's what we're going to work on now. All the different cases. The first one is you just multiply by what's on the bottom. You just multiply the top and bottom by square root of 2 because there's a square root of 2 on the bottom. That's the reason. So the numerator becomes 4 square root of 2. The denominator is the square root of 4. But that should look familiar to you. You should say to yourself, oh, I know the square root of 4. The square root of 4 is 2. Okay.
Yeah.
Now, in many of these problems that we are going to do today, you can simplify here. Now, you can only simplify outside the root. You cannot combine inside the root.
Okay.
And you may wonder, well, why is it over it? I mean, I can dissect that a little more for you, but like you can sometimes do this division here. So in this case, 4 divided by 2 is 2. Your final answer is 2 square root 2.
Okay.
And notice there's no root on the bottom anymore. So these are equivalent. Like this 4 over square root of 2, which becomes 2 square root of 2. These are exactly the same. Like if you went to your calculator and you put that in, you put this in on the right, exactly the same. You might wonder why you do this. I mean, I don't really have the answer to that. You just have to do it.
Yeah.
All right, so we're looking at a couple more examples before I have you maybe try some here. So let's say it's 9 over the square root of 3. So you will multiply the top and bottom by the square root of 3. No big deal, right? 9 square root 3 over square root of 9. The square root of 9 is 3. And you simplify 9 divided by 3 is 3. Something like that.
So you can't combine just a normal number and what's it called?
Something under the root?
Yeah.
You cannot.
Okay.
You cannot. Yeah. It's good you're asking that because I know there's that tendency to think like, I wonder, can I do something? No, no.
Okay.
The reason is this 3 is really to an exponent here under the root, and these are not, so they're not even like terms to really combine. Okay, so let's have you try one here. Let's go 20 divided by the square root of 5. So go ahead and work that out. Give me your final answer or ask me some questions along the way.
Yeah, lost. Okay. So I did 20 square root over 5, and then I multiplied them both by the square root of 5 and got 20 square root of 5 over 10.
So 5 times 5 though is 25 square root.
Oh, okay.
Yeah, so this is the first important point, that when you multiply the square root by itself, it becomes a perfect square root. Like you're gonna know this when you're done.
Okay. So then would the final answer just be 20 the square root of 5?
Over what's the square root of 25?
5.
Yes. Can you simplify?
Yeah, the
Yes.
20 and the 5.
Yes. So that becomes
4.
4 square root 5.
Okay.
All right, so maybe let me give you another one here to try. Let's go 18 divided by the square root of 2. Go ahead and try that, please.
I got 18 the square root of 2 over the square root of 4.
Okay, keep going.
Um,
What is the square root of 4?
2.
2. So there's like several intermediate steps here.
Oh. So you're basically just like combining everything to like the lowest point.
Yeah, it always is the case that the bottom becomes a whole number
Okay.
without the root. And then if you can simplify, you try to do that.
Okay. So then it'd be 9 square root of 2.
Perfect. Yeah. Okay, so this is good. I mean, this is kind of the first type that you'll see. The next type is where it doesn't always like work out. Like let's say it's 4 over the square root of 3,
Mm-hmm.
and you multiply the top and bottom by the square root of 3.
Mm-hmm.
So this becomes 4 square root of 3 over the square root of 9, which is 4 square root of 3 over 3.
Mm-hmm.
Does 3 this can you divide 4 by 3, or can 3 go into 4?
No.
So you leave it. So this is okay.
Mm-hmm.
This is also okay. So I've always struggled to find like a really good analogy, because the analogies never really work out great. But it's kind of like a uniform. Like this is your uniform, but some players prefer to add some things or make it different. They're still the same.
Mm-hmm.
But even that isn't a great analogy here. But you've got to understand, like there's not really any math here. It's just a sequence of things to get the square root out of the bottom.
Yeah.
And sometimes it doesn't work out. Like sometimes you get a fraction here. Here's
Mm-hmm.
another type of problem you might see. We're going to rationalize the top and bottom by multiplying by the square root of 6.
Mm-hmm.
So in the numerator, it's 3 square root of 6 over the square root of 36. The square root of 36 is 6. Okay.
Mm-hmm.
So you've got 3 over 6. That reduces. That's really 1/2.
Yeah.
Okay. Now you could write it like this, 1/2 out in front,
Mm-hmm.
or you could put the square root of 6 in the numerator, 2 in the denominator. And that would also be okay.
How does that second one work though? Like
There's
how
really
does
a
it?
there's really a 1 right there that's not written.
Oh yeah. Okay.
And you have to be comfortable with either format. And
Mm-hmm.
that's what I was trying to show you in the previous one. They're kind of both the same. They're just
Mm-hmm.
different ways to write it.
Okay.
All right, so let's have you try one here. Let's have you try leave one of these up here. Sorry, I'm trying to not make this too odd. 5 over the square root of 10. Let's have you try that one, please.
Okay. I got 20 the square root of 10.
20 square root of 10. Okay, I need a little more information here. What did you multiply the top and bottom by?
Um Square root of 10.
Okay. So the numerator becomes 5 square root 10. Bottom is the square root of 100.
Mhm.
Does that look similar to what you have?
Yeah.
Okay. What is the square root of 100?
10.
10. So now it's 5 over 10. What does
Mm-hmm.
that become?
1/2.
1/2.
Okay, yeah, I didn't break down the 100 after that part.
Yeah. So the reason I ask is I'm always trying to figure out where, like, because there's kind of natural places students go when they make mistakes here, and then I get something like you said. I'm like, well, that's why I ask you to figure this out here. So
Mm-hmm.
again, over and over again, like multiply the top and bottom.
Mm-hmm.
The top becomes whatever. The bottom's always all number. Then you kind of look like, can I reduce that? Does that do anything?
Yeah.
All right. So let me give you another one here to look at.
Okay.
Let's go 9 over the square root of 6.
Okay. I got 9 square root of 6 over 6.
Okay, very good. Now this one's a little bit different because you can't reduce it perfectly, but you can find two numbers that go into both 9 and 6.
Mm-hmm.
So it's like they're both divisible by 3.
Yeah.
So your final answer would be 3 over 2 square root of 6.
Oh, okay.
So you have to kind of keep going. You have to be like, does this, it's like you never know when you're done, but you have to keep
Mm,
going, reduce fractions if you can, things like that.
okay.
All right, so let me have you try another one here. How about 7 over the square root of 3? Why don't you try that one for us, please?
I got 7 square root of 3 over 3.
Perfect.
Okay.
All right. So feel like you've got it, and then I throw something else at you. All right, let's look at something kind of different. Let's say it's the square root of 4 over the square root of 3. Okay. Did you look at anything like this in class?
Yeah.
So the overarching property here is that the square root of a over b is the square root of a over the square root of b. So in your
Mm-hmm.
problem, it's the square root of 4 over the square root of 3. Square root of 4 is known. Now this is a problem just like we've been doing. It's
Mm-hmm.
like, like I thought I was done. No, you got to now rationalize. So like your thinking when you're working through these problems has to be like, okay, I'm going to apply some rules, but if I get it into this format, I have to do all the stuff we've been doing for the previous part of this lesson. So here you'll multiply the top and bottom by the square root of 3. This becomes 2 square root of 3 over 3. So what I'd like you to try doing now is whenever you multiply by the root on the bottom, just write the number. You don't have to
Mm-hmm.
write the square root of 9
Okay.
unless you really want to.
Mm-hmm.
Like at some point, I get tired of doing the same stuff over and over again. I'm like, how can I simplify this? That's what you should be looking for here.
Okay.
So let's have you try one here. How about the square root of 9 halves? Square root of 9 halves. Could you work that out for us, please? It's very similar to what I just
Mm-hmm. I got 3 square root of 2 over 2.
That is correct. Very good. All right. Now this rule on the right here, this works going the other direction. And sometimes we don't think about that. We're like, okay, square root. Sorry, it's not right. You get a problem like this. You're like, all right, square root of 20 over square root of 5. And like instead of remembering that the rule works backwards, that you can write this as 1 square root, you might try to rationalize this, which isn't wrong, but it's like you should always try, like, well, maybe it works out. This is the square root of 20 over 5, which is the square root of 4, which is 2. Okay, so sometimes it works out, but and sometimes it doesn't, and that's where you got to kind of be comfortable with all these different scenarios. So let's try another one here together here. Let's say it's the square root of 5 over the square root of 10. This is the square root of 5 divided by 10, which is the square root of 1/2.
Yeah.
Now, is this better or is this worse? Or maybe indifferent, I guess.
What do you mean? Like,
well, I guess I'm trying to get you to see, like, do you like what we had here, or do you like this better? Which do you, the new one or the old one? I'm sorry.
The new one.
The new one. Okay. So now this becomes the square root of 1 over the square root of 2. And what is the square root of 1?
1.
Good. Now this you still have to rationalize. You still have to multiply the top and bottom by 2. So even though there's a 1 up there, it still becomes the square root of 2 over 2. And that is your final answer.
Okay.
So let's have you try one here. Square root of 8 over the square root of 24. Kind of similar to the last one there. Why don't you give that a try?
I got a square root of 3 over 3.
Yeah, you are correct. Very good. Okay. Excellent. All right. So we're doing a lot of problems today. There's just more variations on this that we have to do, unfortunately. So here's another type of problem that you might see. 5 over the square root of 12. Now, I'm going to come off to the side here. Have we talked about reducing roots, or have you seen that in class?
No.
So you've not seen how to reduce something like this. Is that right?
No, yeah.
Okay. We actually do need to spend some time doing that. So that you've never seen this before. Like, you haven't seen this factor tree 2 and 6 and 2 and 3.
No.
Okay. All right. Well, that's interesting, because these problems here, you're supposed to, well,
I don't think we like covered this part
okay.
yet.
You don't have to, but in a problem like the one on the left here, you can just multiply the top and bottom by the square root of 12, and this becomes 5 square root of 12 over 12. But it could be an issue, and it's let me show you a problem where it actually is. Like, let's say it's 30 over the square root of 18. If you multiply the top and bottom by the square root of 18, you get 30 square root of 18 over 18. You look at the numbers here, and you can say, okay, I can divide both of those by 6. So it ends up being 5 over 3 square root of 18. You're like, okay, I'm done. Problem is the square root of 18 can be reduced.
Okay.
So I guess we need to get to that. Let me go through a few more problems before I do that, though.
Okay.
All right, so here's something we've not seen yet. Let's say it's something like 5 over 6 square root of 2, something like this.
Mhm.
And you know now to multiply top and bottom by the square root, but you might think, well, what do I do with the 6? Well, you actually don't do anything. You just focus on the root. Like it doesn't matter if there's another number here. It's just the root that you multiply the top and bottom by.
Okay.
This becomes 5 square root of 2 over 6 times 2. So you have to be able to be comfortable with multiplying root 2 by root 2. That's root 4. That becomes 2.
Mhm.
So this becomes 5 square root of 2 over 12.
Okay.
Right. Let's try another one here. Let's go like 8 over 9 square root of 3. Why don't
Mhm.
you try this one for us, please?
Okay. I got 8 square root of 3 over 27.
Very good. Excellent. Okay. All right. So we might come back to this. I don't know. There's a few more problems in here I'd like to do with you, but I think it would be wise for us to do this reducing roots
Okay.
thing. So first, before we get to that, have you heard of prime numbers before?
Yeah.
Just heard of it. So the smallest prime number is 2. It's the only even one that it's 3, 5, 7, 11, and so on. We shouldn't
Mhm.
need much bigger than this.
Okay.
All right. And we're going to use this in the next few problems then.
Mhm.
So let's start with the square root of 12. You start with the smallest prime number 2. 12 is divisible by 2. 2 times 6 gets you to 12. And then you try 2 again. You're like, okay, does 2 go into 6? Yeah, 2 and 3.
Mhm.
You stop this factorization when you get all prime numbers on the leaves, basically on the outside.
Okay.
So that's step 1. Step 2 is you look for pairs. So if you see a pair, you can bring a 2 out, or whatever that pair is. Like if you have a pair of 3s or a pair of 5s or a pair of 7s, you can bring that out if you have a pair.
Mhm.
If you don't have a pair, it stays in. So this 3 is going to stay in. So your answers always take on the format of what comes out, what stays in. So in this problem, 2 stays out, 3 stays in.
Okay.
Because we're gonna do several examples here. So if that wasn't clear, you're like, well, I don't really get it. We're gonna do more. Don't get frustrated quite yet.
Mhm.
I'm not going to set you loose and say, all right, here you go. Here's your worksheet.
Yeah.
So let's go square root of 20.
Mhm.
You always start with 2. Is 20 divisible by 2?
Yeah.
2 and 10. And then you try it again. Does 2 go into
Mhm.
10?
Yeah.
2 and 5. That's
Mhm.
why you got to know your prime numbers, because you got to know, oh, I stop here at 5. 5's a prime number.
Mhm.
You look for pairs. There's a pair. You're going to bring a 2 out.
Mhm.
This 5 is going to stay in. Now you don't have to show it this or circle them. I like circling them. I'm only showing you the out and the in. Really, all I care about is that you get the right answer when you're done.
Yeah.
Right. So let's have you try the square root of 28 over here off to the right.
Okay. I got 2 square root of 7.
Perfect. Yeah.
Okay.
Very good. All right. So that moves us to a new type of problem here, like the square root of 45. Okay. So the smallest prime number is 2. 45 is not divisible by 2. So you can't use that, but it is divisible by 3. So
Yeah.
sometimes they do a review of divisibility rules. 4 plus 5 is 9. If the digits add up to a multiple of 3, then it is divisible by 3.
Okay.
So you try 3, 3 goes with 15. Okay. You try it again. 3 goes with 5. This time you have a pair of 3s.
Yeah.
So this becomes 3 square root of 5.
Okay.
Okay. So you go in order. You have to go in order. All right. And sometimes they you don't, there's many different possibilities, but you just go in order and you hope that it works out.
Yeah.
All right, let's look at another one here. Sorry, I'm losing my mind here because I think let's go square root of 18.
Okay.
All right, so you start with 2 and 9, but 2 doesn't go into 9, so it's 3 and 3. So the pairs, it's not like you have to have the pairs in a certain order, meaning like it's not like you have to get the 2s first. You just have to get a pair. So a 3 comes out, but this 2 stays in.
Okay.
So it becomes 3 square root of 2.
Okay.
All right, so let me think here. I got to give you one to try here. Let's see. All right, so let's have you try the square root of 63, please.
Okay. I got 3 squared 7.
Good. All right, now it's okay to actually have more than one pair. So let's look at something like this, like the square root of 32. So you start with 2 and you just keep going. 2 and 16, 2 and 8, 2 and 4, 2 and 2. For every pair, you bring one out. Like that.
Okay.
Okay, so in this problem here, you bring the 2 out, then you bring another 2 out. There is a 2 that's left over, so this becomes 2 on the outside times 2 square root of 2 on the inside. So it ends up being 4 square root 2.
Okay.
So that's the point of this problem, is that you can have more than one pair potentially. So here's another problem here, like the square root of 72. Okay, so you start with 2 and 36, 2 and 18, 2 and 9, 3 and 3. This has 2 different pairs, pair of 2s and a pair of 3s.
Yeah.
So 2 comes out, a 3 comes out, but this 2 stays in. So you've got
What about
2.
what about the 9 right there?
So the 9's been broken apart.
Oh, okay.
So
So
yeah, you actually don't even, you want to, you're just focusing on the leaves.
Okay.
So on the outside, you got 2, you got the 3 you brought out, and the square root of the 2 that stays inside. So this becomes 6 square root 2.
Okay.
So unfortunately, these get like a lot bigger from here. Like there's actually only so many that I can show you where they're not 3-digit numbers. So we now have to move to some larger ones here. But let me have you try this one right here. Let me know if you have any questions. along the way. This one is totally doable. It's just maybe because you haven't seen one in a while or haven't done one here like this. You know, there's more than one number that comes out, I believe.
Okay. Okay, so I did 2 and 60,
Good,
and I broke down 60 to 2 and 30,
good,
and then I did 30 into 2 and 15,
good.
and then the 15 into 3 and 5.
All right. So actually, I gave you a bad one here. So there's only a pair of twos.
Mm-hmm.
So the pair comes out, but
Yeah.
these other numbers stay inside. So it's
Okay.
two on the outside. Sorry about that. I meant to give you one. So but this is okay because you're gonna have to do some like this.
Mhm.
It's not, you know, it's not unreasonable. So this becomes the square root of 30 on the inside.
Okay. So everything on the, if there's more than one on the inside, they all just multiply.
It's just like on the outside. Yeah. If they're more than,
Okay.
let me know when you're ready for another one here.
Yeah.
All right. Let me just do the math here. Make sure that
Mm-hmm.
this works before I give you another one.
Mm-hmm.
Uh, all right, here we go. So this one does work out a little bit better than the last. Take a look at that.
So when I get the pair of 2 and the pair of 3, am I multiplying 4 times 9
No,
or
2 times 3.
2 times 3? Okay.
Yeah. And then whatever's left over here.
Mhm. So 6 square root of 5.
Yes.
Okay.
All right. Let me maybe do a couple more here. How
Mhm.
about the square root of 75? You could try that.
So this piece 3 square root of 5.
It is 3 squared 5. Perfect. Very good. Okay, let's jump back here. So like, you know, we had this diversion here. You may see it slightly differently in class. There's like, this is the way I gave you always works, and then there's like other things you can do to shortcut it a little bit, um, but I think you did really well on that. So
Mhm.
let's go back to some problems we're doing. Like, let's say it's like 9 over the square root of 18. Okay. So we have a couple of options here. We now know that we can reduce the square root of 18, right?
Yeah.
You can also multiply the top and bottom by the square root of 18, but then you actually end up having to reduce the square root of 18 anyway. So it's
That's like
better to
a,
do it now. It's like, if you
yeah.
can, just do it. You ever heard of the 2-minute rule? They talk about this sometimes in efficiencies, trying to get stuff done. And it actually, it applies to math. If you can do something, it, doesn't take that long, just do it. Square
Mm-hmm.
root of 18, come off to the side here, 2 and 9, 3 and 3, it becomes 3 square root 2.
Mm-hmm.
So your bottom is 9 over 3 square root of 2. Now we have not done this yet, but you actually can simplify this first. Like, you don't have to wait to do that. You can make this 3 over the square root of 2.
Yeah.
9 divided by 3 is 3. And then rationalize now, square root of 2, square root of 2.
Okay.
So 3 square root of 2 over square root of 4, which is 2.
Mm-hmm.
So if you can reduce it, you should reduce it.
Okay.
All right, so let me give you a problem here to look at. Let's have you do the 6 over the square root of 12.
Okay.
You'll want to, whenever you're ready, you'll want to reduce the square root of 12 first.
Mm-hmm.
Rewrite it here. See if anything kind of cancels out.
I got 2 square root of 2 over 2.
2 square root of 2 over 2 like this.
Yeah.
So you're almost there, right? Like, those can cancel.
Oh, yeah.
Now, but really, let me actually jump in here because I see something I don't quite like. Um, this should be 6 over 2 square root of 3,
Oh, okay.
which I think you did, but when you rationalize here, and we're doing a bunch of stuff now, so don't give yourself a few problems for you if you wonder if you got it or not. It's
Mm-hmm.
2 times 3. It ends up being 6 on the bottom, 6 on the top, so that's just the square root of 3.
Okay.
Where do you think you went wrong, or where do you think you've kind of got different on this?
Um, I thought, because I was looking in yours, and I thought that's what it was, but maybe I was wrong. Because this is
So yeah,
3.
it let me try to think here. So when you multiply top and bottom by the square root of 3, you could have reduced like 6 over 2 is 3, and then it would have been like there's kind of an intermediate step where it's 3 over the square root of 3.
Okay.
There's a lot of ways to do it here. Like, you have to kind of pick the way you like.
Mm-hmm.
Let's try another one here though. Let's go 10 over the square root of 20.
Okay. I'm a little confused on this one.
Okay.
So,
So what's the
so
let's
I,
square root of 20? What does that become? Let's do that
yeah,
first.
so it's 2 and 10,
2 and 10, and then
2 and 5.
good. So it becomes 2 square root 5.
Yeah.
So this becomes 10 divided by 2 square root. 5 like that.
Okay,
Is that
so
okay? And I would recommend you divide. Like I would recommend you say, okay, I got 10 over 2. Let me divide that. That
mhm,
becomes 5 over the square root of 5.
okay.
I think that will help. And then you have to
Mhm,
rationalize it like we've been doing all night, where you got to multiply the top and bottom by the root.
okay. So it becomes 5 square root of 5 over 5, and the two fives can go together, so would that just be 1 square root of 5?
You got it. Nice.
Okay.
Really good. Really good. Yeah. All right, let's take a look at a couple from this worksheet here. I mean, there's a few here that there's actually another case we haven't done yet, so might as well do this.
Okay.
All right, square root of 7 divided by the square root of 3. So we've talked about the idea that like you could make one root, but the
Mhm,
problem with this is that like this doesn't divide. Like 7 doesn't go into 3, 3 doesn't go into 7. Like this doesn't actually really help. Okay.
mhm,
And so this is a bad path to go down. Okay.
mhm,
You don't want to do that. So your default going back to is, well, you can just multiply the top and bottom by the square root.
mhm.
Now in the denominator, it becomes 3, right?
Yeah.
And the numerator becomes the square root of 21. Now, occasionally you get something in the numerator that you can simplify, but
Mhm,
not in this problem.
okay.
Okay, so this is done now. Even though maybe it looks really weird, there is nothing that like 21 breaks apart into 3 and 7.
Mhm,
There's no pairs.
yeah.
All right, so it's like what do we do? Well,
Mhm,
nothing.
yeah.
So let's have you try this one here. How about the square root of 11 over the square root of 5? It's really similar to the one above it. Give that a try,
Mhm.
please.
I got the square root of 55 over 5.
Yeah. Now it's hard to convince me that somehow what's on the right is better than what's on the left, but this is preferred. Like this is
Okay.
what they want, and like
Mhm,
all right, well, that's what they want.
yeah.
Give them what they want.
Mhm,
All right, let me see what else we got here. All right, so let's look at another one here. All right, so this is 3 times the square root of 6 times the square root of 2. And let's just say you're like you weren't thinking about the most efficient way. You're just like, all right, I know I'm going to always multiply the top and bottom by the square root of 2, which does work. And then you get 3 square root 12 over 2.
mhm.
Is it clear why it's the square root of 12?
Yeah.
Now this might feel like it's done, but you can actually reduce the square root of 12. We've done that a few times. 2 and 6,
Mhm,
2 and 3, it becomes 2
yeah.
square root of 3. So it's 3 times 2 square root of 3 over 2, and the 2's do cancel.
Okay.
Now, when you get an answer like this, sometimes you're like, well, maybe I could have done that better. Like maybe there was a more obvious way to do it. And if you go
Mhm,
back to the original, you can actually use the fact that it's a root there to make this 3 square root of 6 divided by 2, which is 3, which becomes 3 square root 3, which is the same.
yeah.
And that shows you that there's like a variety of ways to get to the same answer. You just have to pick a path. pick a
Mm,
strategy. I mean, when you're dribbling down the floor, your coach doesn't care how you get it down the floor as long as you get it down the floor, I'm assuming,
yeah.
most of the time. I mean, I'm gonna
Hmm.
be careful there, but in golf, I play golf and there's no pictures on the scorecard. So it's like if I make a par because I hit the fairway and green and two putted, that's great. Or if I, topped a drive, hit a 3-wood up by the green, chipped up and made the putt, same thing.
Hmm.
You have to
Yeah.
choose how you want to do it. You have to like say, all right, I see it this way. I'm going to attack it this way. The more math you do, the more you get kind of a choice.
Yeah.
Okay. So just keep that in mind here.
Hmm.
All right. Well, we have definitely maximized our time for
Yeah.
today.